Hey, what's up? Tristan from Huge Menace here. Welcome to part 5 of the ND add-on deep dive series. In this video, we'll cover extrusion. All the extrusion operators in ND are focused solely on pulling 3D objects out of 2D profiles or shapes. If you've ever used software such as Fusion 360 or SketchUp, you may already be familiar with extruding shapes from 2D sketches. This particular process inspired the inclusion of sketch and extrusion operators in ND. However, because we're working in Blender, not a CAD application, ND only implements a subset of operators supported by the modifiers available in Blender. Still, they're instrumental and some of the most used operators next to bevels and booleans in many everyday non-destructive workflows. Let's get started. First on the list is Solidify. For the Solidify operator to work correctly, you must run it on a manifold shape. In this example, let's start by using a plane, which is naturally manifold. Select the plane, and from the Extrusion submenu, select Solidify. The first parameter we can change is thickness, representing the total amount of extrusion. When dealing with a simple starting shape such as a plane, it's how tall the object would be at the end of the operation. One thing to note is that the default behavior for this operation is to extrude equally in both directions. Suppose the thickness is set to 200. In that case, it will extrude 100 units in a positive direction, or upwards for this particular object's orientation, and 100 units in a negative direction. If you would rather have the entire extrusion performed in a positive or negative direction, you can select it from the weighting options. Neutral is the default. After that, you can displace the object by a specific offset. This is optional but helpful if your initial target object needs to be aligned with another object or if it's too high or low given its starting position. Last up is mode. Like Booleans, which have two different solvers, fast and exact, mode has two options, simple and complex. 99% of the time, simple is all you need. Still, there are times when complex mode produces a more predictable and accurate result, but at the cost of some additional processing power. Let's examine this. Here we have a mock architectural floor plan with the walls defined as planes. We want to add some thickness to them, so let's select Solidify. After adjusting the thickness, you'll notice some odd geometry being generated. In this situation, the simple mode's lack of precision results in a less than desirable result. Thankfully, switching over to complex mode results in much cleaner geometry. Okay, let's talk about the next operator, screw. The screw operator will take any profile you've created and revolve it around a specific axis. So, step 1 is creating a profile. I'll use a spark plug profile I've prepared for this demo. In this case, I've specifically only drawn out one half of it, as I want to revolve this profile around the z-axis, resulting in the cylindrical shape of the spark plug. If you're curious about how this profile was created, I started with a single vertex. I extruded it along each point of the spark plug. Then I used numerous strategic vertex bevels to introduce the required curvature in a non-destructive way. We'll cover creating profiles like this in future tutorials. Anyways, with the profile defined, let's select it and perform the screw operation. The first parameter we get to change is the number of segments. This should be familiar if you've watched the video on ND sketch operators, circularize and recon poly. The more segments you add, the more defined the object becomes. Much like recon poly, you can go as low as 3 segments to create a triangular base, or 4 segments to create a square base. Higher segment counts then continue to create a more defined circular shape. When using the screw operator, you might find that the shading of your object doesn't quite look right. This is due to the way the resulting object's normals are calculated by Blender. However, it's easy to fix by tapping the F key to toggle the flip normals parameter. The following parameter, angle, defines the maximum revolution angle. It's set at 360 degrees by default, but you can change it to any angle between negative 360 and positive 360. Let's quickly look at an example of where this is useful. I'll stop working on the spark plug and switch to another demo I've prepared. Here we have two objects. The first is a cube that I've cut using a difference boolean. The second is a plane that lines up with the top face of the object on the right-hand side. I've also specifically ensured that the plane's origin isn't at its center, but offset to the side and aligned with the z-axis. I want to achieve an arch over the top of this base object. Seeing as the screw operator revolves geometry around its origin point, this will ensure that the middle of the archway lines up correctly with our base object. So let's select the plane and run the screw operator. Now, the z-axis is selected by default, so let's tap A a couple of times to use the y-axis. I'll then increase the segment count to get a nice looking result. For this case, though, I don't want a complete 360-degree revolution, as that results in nasty intersecting geometry. Plus, it's not an arch. This currently looks more like a donut. So let's start playing with the angle parameter. In this situation, the revolution is occurring clockwise. Let's keep decreasing the angle into the negatives to go counterclockwise. Once we hit negative 180 degrees, we get the result we're looking for. Okay, let's jump back to the spark plug and continue on. The last parameter to talk about here is the offset. The offset takes the base geometry and offsets it along the specified axis before performing the screw operation. By default, the offset axis may not be correct. However, you can easily change it by hitting the O key. In this example, we can slightly offset the spark plug's profile and make it look like an air hose connector. Alright, let's take a look at the final extrusion operator, profile extrude. Like the spark plug, we'll start with a profile. With it selected, let's run Profile Extrude. Profile Extrude was designed to work in a very similar fashion to the Solidify operator. The first parameter, extrusion, is the total length of the resulting extrusion along the given axis. If the axis isn't correct, hit the A key to cycle through them. Like Solidify, it will extrude outwards from the center in equal positive and negative directions. If you wish to only extrude in one direction, hit W to change the weighting. You can also adjust the offset if required. Much like the screw operator, Blender needs to calculate the surface normals of the resulting object, which, if they don't look correct, you can alter by hitting the E key to toggle the Calculate Edges parameter. This works in a similar way to flip normals. Well, that wraps up extrusion. In the following video, we'll look at the replicate operators. I'll see you there.